Again, how many do we have now? 23. The number that eggs and sperm should have. So we do through a duplication process. We have to duplicate, have to make copies. But that totally screws up our numbers. So then we go through 2 rounds of cutting in half. First we double, then we go cut in half, that gives us back to 46. Cut in half again, that gives back to our 23s. Now, this, in a sense, is a pair of chromosomes. It's a pair in the sense that they have the same genes. This is what's known as a homologous pair. In this homologous pair, where it's the same version of chromosome from mom and dad, that's been copied, how many total chromatids do I have in this picture? No. How many do I have in this picture? No. How many do I have in this picture?
Oh, 2.
No.
4.
How many in the picture? Lynn, wake up, young lady.
4.
You got 4, right? 1, 2, 3, 4.
Okay.
Oh, Sister
We're going to go back to kindergarten and learn how to count, young lady. We have 4, right? So, a homologous pair is also what's called a tetrad.
Lord. Oh. Tetrad.
See the tetra part? Tetra means 4.
T-E-T-R-A-D. T-E-T means 4.
So what I can then say is, if this is called a homologous pair, and I hate the person that ever created that word, we'll argue about him later, the first round of meiosis then is separating the homologous pairs. Right? I don't have homologous pairs in here anymore. So we separated them.
So wait, homologous pairs are when you join mom and dad's chromosomes together?
After they've copied each other, right? Because you've got 4 chromatids now.
Okay.
So they
Right.
complete each other.
So-
Homologous means the same.
Homologous.
So is this happening once mom and dad join together? Like,
No, this is happening,
before?
well, it's happening in my sperm cells.
Right,
It ain't happening in you anymore.
right, because eggs are already all created.
Exactly. We'll get to that discussion later. Right? But when you were making your ova, you were doing this. When males make sperm, they're doing this. So we separate the homologous pairs. What are we separating now to go from here to here?
The sister chromatids.
Exactly. You're separating sister chromatids.
So you separate the pairs
Right.
in one.
So first we
the
separate
sisters
homologous
in two.
pairs, then we separate sister chromatids.
Okay.
Don't worry, we're going to walk you through this, and don't worry, you're going to do this in lab with colored pencils. You're going to get lots of practice with this.
Is there,
All right? So let's go through it and look at this stuff here. Here's the first stage of meiosis. The names of the stages are exactly the same as they are for mitosis.
that's what was
Cool.
confusing.
I get to use them over and over again.
Okay.
All right? So,
Ah,
but this is meiosis 1. So here's how you have to talk about this. There's interphase. So we're making copies of all of mom and dad's chromosomes. We're going to have homologous pairs when we're done. But we need to condense the homologous pairs. This is called prophase 1. You do not need to say prophase 1 of meiosis 1. That's redundant. If you say, John, I'm studying prophase 1, I know you're looking at meiosis. If you simply say,
enter.
go ahead, get it open.
Sorry. So prophase 1 is when they're making a call.
Okay. If you simply say prophase, it's mitosis. She's having a bad morning.
I love Lynn.
Okay.
She makes it work.
So if you study prophase 1, we know it's meiosis. If you say prophase, you know it's mitosis. Because the Roman numeral tells me which version of prophase we're doing.
And prophase 1 does what?
It's the same thing that prophase does. Nothing different.
Prophase 1 does the same thing as prophase, so,
All right, so you can study that part. Let me get on to
Prophase
the
1.
next little
Okay.
step here.
okay.
All right, so with the nuclear membranes breaking down, centrosomes are moving to opposite poles, right? There's my homologous pair, right? You can see that if this is mom, she's got her 2 chromatids. If this is dad, he's got his 2 chromatids.
Right.
Now, here's one thing that's different. Why are there, shh. Why are there two black circles here? Because it wants your attention. Say, looky here.
We're not separated yet.
Imagine that these are two people laying in bed, right? I've got my two arms, I got my two legs, right? So I'm laying in bed like this. And then here's my bed partner. She's laying in bed, or he, it, whatever it is, right? Laying next to me. I'm going to take this leg and cross it over their leg. I'm going to cross my legs over. That, see the picture, is called crossover. They're crossing over up here as well. So we're looking at crossover happening only in prophase 1. And it is literally, if you look at the picture here, let's do it like this. I'm going to take this chromosome here and make it black. I'm going to make this one and make it blue over here so we can see there are two halves. We're going to kind of draw it a bit like this just to make it a little easier to see. Kind of like this, right? And then I'm going to have the blue one, so they're doing it a little more like this. That's not going to work. No. Got to come down here, and then coming down like this, and then there's going to be my. All right. What I'm trying to let you guys see is that you see how we have chromatid A and chromatid B, chromatid A and chromatid B, that it's the two sister chromatids that are side by side that do crossover. This one is not involved in crossover, and neither is this one. It can only be the chromatids that are side by side that can do crossover. When you're done with this, it'll look like this in reality. That may not have shown up too well through a different color. And this is going to be blue. So we're going to be this. And then we're going to be this. What's different is the black one now. Make this, whoops, wrong color. Make this really stand out. Before crossover, the black chromosome was totally black, right? The blue was totally blue. Is the black one now totally black?
No.
Is the blue one totally blue?
Yeah.
You have literally, you're going to say no.
Oh, no.
It is literally, when they do crossover, they swap, they exchange the genes found on that part of the chromosome. You literally swap the genes that are found on that part of the chromosome. So let me ask you this. Is this homologous, is this black chromosome now the same down here?
No.
No, it's got now part of dad's genes and mixed in with mom's genes. That provides variation. That provides differences. So at the end of prophase, after we've done our crossover event between the two adjacent sister chromatids, now they're lined up in metaphase. Right? We know what happens in metaphase. We separate our chromosomes. But now we're separating what exactly?
Sister chroma.
No. What are we separating exactly
Oh, the
here? You go from
centrome.
here to here, what are we separating? Separating the tetrads. What's the other big, more formal, fancy word? We're separating.
The homologous
We're separating
pairs.
homologous pairs.
Aw, man.
But they've already done their crossovers, right?
Forgot that was another
So
thing.
now, at the end of anaphase, after having separated my homologous pairs, we can see the crossover happening here on the next slide. Right? You've got your homologous pair. Mom's chromosome has been duplicated. Dad's chromosome has been duplicated. I have 1, 2, 3, 4 sister chromatids with the same genes, just mom's versions and dad's version of the genes. Now they're doing crossover. Look at the lettering. 2 capital D's, 2 lowercase d's. The mom only has capital D's, dad only has lowercase d's. At the end of crossover, one of mom's chromatids only has the D, but the other chromatid now has a little d. You got that from the crossover event with dad's chromosome. Now we have differences. We have different genes on the chromosome that we didn't used to have. As we go through this, now we need to do meiosis 2. But think about what happened by the end of meiosis 1. How many cells should we have? You're going to have 2. Right? Because we split them in half. We separated our homologous pairs so that each cell would get this set of chromosomes and the other cell gets this set. So now we have 2 cells.
So after phase 1, it was metaphase where they met in the middle, right? And then anaphase where they separated into
Same thing,
two?
yep, nothing
Okay.
different. The names are always the same.
So anaphase where they separated.
All right, so now look over here. All right, here's the end result of meiosis 1. Right, I've got 2 cells that now have to start all over again. But they're not going to make copies. They're not going to do S phase. They're going to break down their nuclear membrane again, because the dumb thing forms up for the round 2. God knows why it does that. I don't mean that literally. All right? So now, my new centrosomes have to move to opposite sides. So this is like prophase all over again. This is called prophase 2. So don't say prophase 2 of meiosis 2, that's redundant. The only prophase 2 you have is because of meiosis. Remember, mitosis doesn't have 2 rounds. So now we have to condense our chromosomes again. We're going to have our centrosomes on opposite sides, microtubules going across, everybody lining up in the middle. So now I need to separate my sister chromatids. So now they're going to contract. Now we're separating our sister chromatids. Separating sister chromatids, and then each one of these cells, right, is going to go through telekinesis and cytokinesis. So when I'm done, I'm going to have 2 cells here and 2 cells here. That gives me my 4. The big special ideas you want to think about is that when we're looking at mitosis and meiosis, we only have 1 round of division. We start off with 1 cell. How many cells do we have?
2.
We start off with 46 chromosomes. How many do we have in each cell?
23.
No, you have 46.
In each?
In each, yes. In each. Remember, this is mitosis. Exact copies, like a Xerox machine.
Okay.
You go over here. Here's meiosis. First of all, see, here's the end of meiosis 1. Here's meiosis 2. So if I start off with 1 cell, how many cells do I end up with by the time I'm all done? You've got 4, right? Now, I started off with 46 chromosomes, 23 pairs. How many do I have by the time I'm all done? 23, exactly.
Okay.
Not 23 pairs,
23.
23, right? We have this. And that's because we went through 2 rounds of dividing. That's because I first need to make a copy of all of my chromosomes in my future sperm cell, in my future ova. It actually doubles the number. So if I have 46 here, I'm now going to have 92 up here. Well, that's okay. The homologous pairs line up. They're showing you crossover. Right? I get from metaphase, my homologous pairs get separated. I go from 92 to 46. I then separate the chromatids so that each cell gets its share of chromatids, its version of that. I go from 46 to 23 each. So we first have to double, then we reduce in half, then we reduce in half again. That's why it's called the reduction division. You're going to need to practice this. That's part of the intent of Lab Book in the future. So, how many cells do we start off with in meiosis? 1. How many do we end up with when we're all done? 4. Okay. If we're looking at a normal human, how many chromosomes do we start off with? How many chromosomes do we start off with?
Oh,
How many chromosomes do we start off with, folks? How many chromosomes do you have?
23.
Don't pick on me, I don't know. Otherwise, how many numbers? 46, right? What is the number of chromosomes at the end in each cell?
23.
23, right? Is it pairs?
Separating them.
No,
It's individuals,
yeah.
right? 46 individuals, 23 individuals. So how is meiosis different compared to mitosis? That's for you to do. Go through it, make a list of what's the similar and what's different. So that's a little bit of practice. I don't have enough time, I don't think, to show you the video to go with it. Right? And we're not done. We're going to spend a little more time on this. Let's try this. No, let's do this. Where'd it go? Okay, let's do this. Okay. Gotta add a little fun. All right, so this is one of, God knows how many video clips I have from my animal behavior class. There are a lot. This is about mating, the intense drive that males have. This is a flightless parrot in New Guinea who's evolved to not need wings because he has no land-based predators to worry about.
Oh, I see. Is he up there? Where is he? Yes, I can see him. I can see his outline. I still can't see him. No, in that thing there. Just that. Oh, yes, yeah. Oh, well done. Yeah. Yep. I suppose no prehensile tail for climbing like a monkey. No, so there's no beak. Oh, yes. I love the sliding. Well, what Douglas said about the kakapo was not only having forgotten how to fly, but it had forgotten that it had forgotten how to fly. And that very often it would sort of jump out of a tree as if expecting to fly. But